morning. Thanks for being here. I'm Marcel Schutte, and I'm going to tell you something about software architecture. Of course. Yeah. I've been a lead solution architect at Asoh for the past 3-4 years. First off, I started off as a Java developer back in, I think, 2006, long time ago. Just forget about that. But in those 20 years, I've been working with a lot of architects, some good, some bad, and I try to gain their knowledge, see how they were doing their job, how they were how they were doing their job, so I could one day become a better architect myself. In the past 20 years, a lot of things have changed for architects. We once started out with architects in their ivory towers, creating big upfront designs with their need to be an actual perfect solution. And once they got the solution done, they just threw it out the window, gave it to the development teams, and didn't look back. Those times have changed. For now, with the emergence of new technologies, faster release cycles, we actually get a more collaborative way of doing architecture. Also, DevOps and all those things helped to make sure that architects needed to be more involved with their teams. Now, this is the agile transformation for the architect. We started out with a very big design up front, and then just the development afterward. We moved from the big design up front to just-in-time architecture, doing a little bit of architecture every sprint and until the project was done. And it was improved by doing just-in-time, just-enough architecture, which basically means you do the right amount of the right thing at the right time. And we moved on from a mindset of we need to do everything perfectly to good enough is the new perfect. You start out with an idea, you start with developing it, and you adjust and adapt as you go along. Now, the very next natural step from just-in-time, just-enough architecture is evolutionary design. And evolutionary design, it's not an unplanned, chaotic, just do architecture. No, there's still a plan with incremental change and making sure your team can give continuous feedback all through the lifetime of the project. And in that way, you can actually create very resilient architectures, which are able to change over time and evolve with the new things that change in the requirements. Well, in those past 20 years, I've seen something very specific, and this is probably one of the most important parts I want to share with you. It's that the systems you create follow Gall's law. I'll show Gall's law in a minute, but also the systems you use to create those architectures are abiding by Gall's law. Does anybody know what Gall's law is? I see 2 hands. Cool. Thank God, I've got it on a slide. A complex system that works is invariably found to have evolved from a simple system that worked. You start out simple, you evolve to a more sophisticated system, more complex. As I said, what I've seen over the years is that also the process you use to create those architectures follow the same, law in this case. You start out with a basic plan and basic toolkit, basically, from which you create your architectures. I'd like to call this being a pragmatic architect. We'll see what it entails for me, because I've identified basically 3 areas of tools techniques which are at the heart of the architect's work, basically. We've got diagrams, and diagrams are my way of sharing my vision with anyone in an organization, from CIO to developer. It gives a lot of information in a high density, and as a picture says, more than 1,000 words. To me, documentation is not just a very big document, but small documents with small changes. And it gives the context of the journey, how we got to this system that we are, where we are now. And also, it should be a collaboration of the documentation. It's not just an architect that creates those documentation. You should be able to share it with the team, and also the team can work on the documentation itself. And it really drives agile development. And for me, fitness functions, those are basically measures that I've put in place to make sure my architecture still adheres to the rules I've set at the start, so making sure it still adheres to my key qualities I set for the system. The integrity should be intact. And for these three things, I use 3 tools to make it a little bit more practical. I use for diagrams, I use the C4 model, which is a very lightweight framework of creating diagrams with various layers of abstraction to show, to use in very different contexts. Talking to the CIO, you need a high-level one. Talking to the developer, you need a detailed one. And C4 makes that very easy. For documentation, I use ADRs. ADRs are small pieces of documentation containing choices you've made in the run of your project. You put in your context, pros and cons, and why you actually decided on taking that solution. And for the fitness function, just an example, I've used the arg unit. I do a lot more of those for fitness function, but for now I'd like to focus on arg unit. Well, let's have a look at C4 diagrams. As I said, because of C4's abstraction layers, you can actually easily create a lot of diagrams with a different layer of abstraction. You can put a whole lot of information in there, and it makes it easier to communicate your vision about the architecture. Because it has a DSL, it makes it possible to actually work with plain text files. And as a former developer, I really like plain text files, because updating pictures is, well, troublesome. Let's leave it to that. Because let's have a look at first, I built a model of my system, which is basically this, just a couple of entities. Architects draw boxes and lines. These are the boxes. You can put them, well, you can identify any item in your system, and then later on create the relationships between them. Very simple notation, just one box, the other box, and an arrow in between creates a relationship between those two boxes. Now, this is all I've done for this very small application. But by adding these 3 different views of my model, it can generate 3 different diagrams. All 3 diagrams are generated from the same model, just every time you go a little abstraction layer down to get more detail. You can start out with system context, the container and the component diagram in this case. And that is how I like to use my diagrams. And because it's plain text, you can put it in your Git repo with your application. You can also get a history of your diagrams, which is way easier to do with plain text files than it is with pictures. Right. Architecture decision records. main thing for me for the architecture decision record is it captures the context of your choices that you've made along the way. You're not going to generate a very large document of your entire architecture, because every time you make a change, you have to go through the entire document and change everything that's needed. Now you can just add a decision record and sometimes add to another one and just say, all right, this one was the right decision at the time. Now it's superseded by the one we've taken now. And that way you can just move ahead. Once again, I'm a developer at heart, so I also like to use plain text files for these. And therefore I really like the template supplied by adr.github.io, which makes it, once again, easy to put it in a Git repo and also have it version controlled. So, a little bit more detail. Once again, you put your context in, the decision you've made, the different solutions that were possible, because you never decide, okay, we're going to do this. No, you also decide those things we're not going to do. We want to do a microservices architecture and not the 3-tier layer, the onion, the hexagonal, whatever. But you do have to talk about it in your decision record. Why did you choose for the one and not the other? I put the pros and the cons in there. And there are some extra fields you can use, but the status is probably still an important one in here, because you want to know, make sure that you know what the status is of an ADR. Is it active, or is it superseded, deleted, or whatever? All right, let's have a small look at argunit. Argunit is for me a fitness function to make sure the integrity of my application is in line with the set rules of my architecture. Let's have and because it's basically a unit test, it can run in your pipeline in your standard testing suite. Let's have a look at an example. This is a very basic 3-tiered layer application going from presentation to service to persistence. There are very specific rules for this architecture. You can't go from the top layer to the bottom. You can't go from view to persistence. And you can't go up, basically. So these are very nice to catch in a unit test. Let's have a look at this. Argunit is way bigger than this, but just an example to show you. You define your layers and your constraints for those layers, and from there on you can just build your test set for your architecture. Just a nice example. All right, let's recap. For my process, I really like to keep it simple. Make sure you have good tools for your 3 main areas, for your diagrams, documentation, fitness functions. As I said, I like to use the C4 model, ADRs, and argunit. And that all lead, for me, what I'd like to call to pragmatic architecture. Thank you.